Hi everyone, welcome to your quiz 2 review video. As you know, we have our quiz this week, and in this video I'm going to be sharing some tips for quiz 2. I'm also going to be going over some important questions that I feel everyone should be familiar with and confident with before the quiz. I'm going to share a list of questions I've compiled from your tutorial as well as homework videos, which I feel you should revise or revisit before taking the quiz. You could either redo them yourselves or watch the videos for them. It's up to you depending on how much time you have at hand. And finally, I will also solve 3 of those questions with you. So let's start with a short overview of the quiz. So as you know, it's on this Thursday and this Friday. For group 1, it's June 24th. It starts at 2:30 p.m. and ends at 4:30 p.m. EST. For group 2, it starts at 7 a.m. EST and ends at 9 a.m. EST. The length of the quiz is 120 minutes or 2 hours. It has been extended from the last time. And the number of questions still remains 6. Out of these, 3 of the questions are going to be 2-star questions and 3 of them are going to be 3-star questions. So please be really careful with time management this time. We know that a lot of students face that issue in the last quiz. Try to not give yourself more than 20 minutes per question. For the longer questions, the 3-star ones, you could probably spend 30-ish minutes, but then you definitely need to compensate by spending lesser time on the easier ones. All right? The number of attempts per question has also been increased. It's 3 now, and the latest submission is graded. So after 3 submissions, your submit button will become inactive. However, if you don't have 3 submissions, if you just submit once or twice, then like the latest submission will be graded. All right. So be really careful before you paste your code on MATLAB Creator. You don't want to waste your attempts on silly mistakes. So make sure you debug everything on your MATLAB, the software, and only then copy paste on MATLAB Creator. And yeah, just make sure you are on track and keep yourself in check with a timer next to you, and definitely keep track of the time. All right. Also, please check out all the guidelines under in our GitHub. So if you go to our main page, and this is our computational methods, and here if you look at the reading list, the first link here is June 18th instructions for quiz 2, and if you click on this, you're gonna see a whole page detailing the general description, the schedule, the submission and grading, and any kind of technical interruption issues. Please make sure you read all of this before your quiz so you can ask us any questions if you have any before the quiz. Hi, so the first concept I want to draw your attention to is the difference between numel and size. These are both built-in functions that help us kind of get an idea about the number of elements in a vector or the size of the matrix or the vector. However, the outputs of both of these are quite different, so you need to be careful while using them. Okay, so I have randomly generated a number between 1 to 10. I've made a mat A which has 3 rows and n number of columns, and I've generated a vec A which has 1 row and n number of columns. All right, so my first variable right here is num mat A, which is the output of numel of mat A. And this is num vec A, which is numel vec A. So I'm going to comment the rest of the things out. Oh, my bad. I'm just going to copy all of this. I'm going to comment them out, and I just want to run these two to see what does the numel function do. So let's run this. Okay, so my num mat A is 6 and my num vec A is 2. Okay, so here I can see vec A has 2 elements and mat A has 1, 2, 3, 4, 5, 6 elements. All right, let's try to run this again. So this is a 3 by 8 double, and this is a 1 by 8 vector. Num vec A is 8 and num mat A is 24. So basically what the numel function does is gives you the total number of elements in a matrix or a vector. All right, so that is what numel does. I'm going to write that right here: total number of elements. Okay, so now let's move on to size. So here I have size mat A for size of mat A and size vec A for size of vec A. So I'm going to uncomment this and let's run it. Okay, so here do you see that size mat A is not a single number, it's a vector. It's a 1 by 2 vector, and so is size vec A. So what size does is returns the number of rows and the number of columns. So mat A, as we know, is a 3 by 2 matrix right now, and vec A is a 1 by 2, and that's exactly what it is. It should be 3 by n and 1 by n. Let's run it again. Oh, my n value is 2 again. Let's try again. Okay. Now my n value is 6, so ideally my mat A should be 3 by 6 and my vec A should be 1 by 6. Is that the answers? Yes, exactly. So always remember, size gives you the actual dimension, so it'll be a vector with like your row dimension and your column number of columns, and numel gives you the total number of elements. Okay, I'm going to comment that right here. Number of rows and columns. Output is a vector. Okay, and finally, this is a variant of the size function. Here, instead of just writing mat A, I have also specified the direction in which I want it to be. So let's uncomment these two lines now. All right, and let's run these. Okay, this is the row and the column. Okay, so do you see how this has now split up the answer of the same one? So here, when I say mat A and comma 1, it is giving me the number of rows, which is 3. And when I'm saying mat A comma 2, it's giving me the number of columns, which is 7. Okay, so always remember, 1 will give you number of rows and 2 will give you number of columns. If you're ever confused about this during the quiz, I would always recommend making like a small matrix or a vector and running these functions quickly to check what the output is and then using it in your question. The next important question I want everyone to be familiar with is looping through a matrix. So there's multiple ways to loop through a matrix and multiple reasons to do so. So we're going to visit a few of them right now. The first one is to loop through the diagonal. So if I run this code, just the given code, and also you can only have a diagonal for a square matrix because rectangular matrices don't have like a proper defined diagonal. So that's why I have changed the dimensions of my mat A from 3 to n to n by n. All right, so this is like a perfect square matrix now. My n value is 1, which is not exactly useful for me. I'm going to run it again. Now it's a 9. Great. So if I look at mat A, what is my diagonal? So it's 7, 15, 2, 15, 5, 20, 2, 1, 8, right? So if I take a look at this whole diagonal, I can see something special about the elements. So 7 is row 1, column 1. 15 is row 2, column 2. 2 is row 3, column 3. 15 is 4, column 4, and so on and so forth. So for the diagonal in a square matrix, the row value, the index of the row, is going to be the same as the index of the column. So this is an important concept we're going to use when we are going through the diagonal. All right. So I'm going to start with my for loop. So in this particular question, I'm assuming I want to loop through my square matrix and make all the diagonal elements 0. Okay. So I'm going to start with my for loop, which is like for I equals 1 to n. And then I want my j loop. So my for jj equals 1 to n. Okay. Why am I starting at 1? I want to go from the first element. And why am I stopping at j? I want at n, I want to go to the last element. All right. And my size is n by n, so my last element is n in both cases. Okay. And now I say, okay, so the special thing we saw about the diagonal was that the ith index was same as the jth index. So if my I index is equal to my j index, then my element at that place should be equal to 0, right? So there's a difference between II and like mat A bracket II. So here I'm going to write mat A bracket II comma jj equal to 0. Okay, a very important part of this is what is II and jj? They don't exactly mean anything, right? When I'm defining II and jj for my for loops, I'm just saying that it starts at 1 and it goes to n. So it's basically just a range of numbers. It does not mean anything. It's you who are writing the code when you give meaning to what you want to define II and jj as. So here, since I've written II at the first position, that means II is the row value and jj is the column value. In common convention, we always use II as the row and jj as the column, but that's not always true, especially if you're dealing with a vector. You can use II and jj as just referring to different elements within the vector. We'll take a look at those kind of questions too. Okay. So in this particular situation, I am checking if the indices are equal to each other. And if yes, then I want the elements in the position to become 0. So please note the difference between just an II and JJ and mat A bracket II comma JJ. And always remember, when you're using two of these numbers, it's you're referring to the row and the column. If you're just using one number here, that becomes linear indexing. So be really careful with that. Okay. Another way to go do the same question is I'm going to write optional here, and using just one loop, I can say for I equals 1 to n, and I can use I to index my row as well as my column. All right, so I can say mat A bracket I comma I equal to 0. So only when it will only go to those elements where the ith row and the ith column, so it's the row and the column have the same index, and change them to zeros. Okay, so this is also a valid code. I'm going to comment this out because it's optional. Okay, let's take a look at the next one. So sum of all elements. So for sum of all elements also, I'll take a very similar approach. Please remember, you can also sum all elements in a matrix using the sum built-in function. I'm just teaching you how to do it with loops because it's slightly different. And also I want all of you to understand how loops work through a matrix. All right. So we'll start with our I loops. We'll say for I equals 1 to n, again, because my mat A is n by n. All right. And I'm using I to index my rows in this situation and J for my columns. So here I'm going to say for JJ equals 1 to n again. All right. So here, what do I want to do? I want to add my every single element of my matrix and store it in a variable called sum. So at the beginning, I should have defined a sum. I should have said sum equals 0. Make sure it's outside the loop. If it's inside the loop, it's going to become 0 again every time the loop runs. We don't want that. We want sum to be outside the loop. Okay. So here I'm going to write sum equals sum plus, again, here be really careful. I've seen lots of people write something like just II comma JJ. This is incorrect because II and JJ just by themselves are numbers. And when you're writing something like this, you're just saying sum plus two numbers, which does not exactly make sense. You want to add the element of the matrix. So you have to write mat A. And in the bracket, you have to write II comma JJ. So I am ending it here, I'm ending it here. So this is the way to sum all elements using nested loops. Another way to do it is also using a single loop and linear indexing. So I'm going to write that as the optional script. Here you need to be really careful because if I am using linear indexing, then my loop would not just run from 1 to n. Because think about it. If in this situation my n value is 9, my mat A is a 9 by 9 double. So when you're using linear indexing, you refer to each element individually, right? And if I loop from 1 to n, that would just loop me from 1 to 9. But that's not the number of elements. My matrix actually has 9 by 9 elements. So here, instead of 1 to n, I need to use the numel function, okay? Because numel gives you the total number of elements in a matrix. So here, I would loop from 1 to numel mat A, and then I would say sum actually. Sum equals sum plus mat A and just a simple II. End. Okay. So both of these codes will give you the same results and they are both interchangeable. They're the same thing. Pick whatever you're more comfortable with. Just make sure you know the difference between the two. All right. I'm going to comment this out too. The last concept is a really important one. It's isolating a row or a column from a matrix. Okay. So sometimes you'll have a big matrix and you don't want to deal with all of that. You just want to deal with one particular row of the matrix. So how do we do that? We say for, we will start with II equals 1 to n. And then I will say my colvec equals mat, this should be small. So mat A. Okay, so which half do we use to refer to the columns? So the first number is always the number of rows and the second one is columns. So all rows, comma, ith column. All right, that's how I would isolate a column in every loop. And to do the same for rows, we would say row vec equals mat a. This would be I, comma, all. All right. So be careful which ones you're using for the call vec, which ones you're using for the row vec. Okay. Another concept you've come across often in your tutorials as well as homework questions is using counters. So counters are increasingly simple variables that are used to keep count of whatever you're looking for. It is literally the MATLAB equivalent of keeping count of something on your finger. So it's really easy and you just need to understand where to place it. All right, so suppose we have this vector, it's a 1 by n vector, and I need to see how many times the number 3 occurs in this vector. All right, so I'm going to be using the counter in this way. I'm going to start with my for loop. I'm going to start at I and I'm going from 1 and I'm going till n because that's the size of my vector. And then I'm going to say, oh, sorry. Okay, and then if I encounter the number 3, so I'm going to say if vec a, and what a vec a, like the ith element of vec a, right? Because I'm looping through vec a. So if the ith element of vec a is equal to 3, then I want my count to increase by 1. So count equals count plus 1. And before doing any of this, I should have said count equal to 0. All right. And end and end. So basically what's going to happen is that you're looping through the entire vector. You're checking each element. And if any of the elements is equal to 3, then you're increasing the counter by 1. Okay. That is a very easy concept and that is what it is. Oh, I have made a mistake here. Oh, unrecognized variable, n, my bad. I should have copied n from here. I'm going to copy this and I'm going to paste it right here. Okay, now let's try running it again. All right. So I have my vec a right here and the count says 1. So let's go and check my vec a. 1 by 9 double. Do we have any 3s? Yes, we have 1 3 and that's exactly what count gave me. Let's try running it once again. Oh, it says 2 this time. And let's check my vec a. I have a 3 here and another 3 here. Perfect. Built-in functions are an important component of Module 5. That's pretty much the whole of Module 5, and that's why you should definitely have a really good grasp of all of the built-in functions that's mentioned in Module 5. If you're unsure about the syntax, please make sure you have your notes close to you while writing the quiz and have all the syntax of the different functions written with you. All right. So here are a few important built-in functions that have been covered in Module 5 that you should review. So the first one is reshape. How reshape works is that you have your mat, the matrix you want to reshape, and then you have the required dimensions given here. Please note that you need to use these square brackets here for this. And here I have my n by n matrix, and that's why I've made it into a 1 by n square. Make sure the reshaped dimensions match the actual number of elements in the matrix. All right. The second one I have is flip. So here I have not mentioned the direction for the flip. However, if you look at your notes, so if no value is specified, then the default is 1. 1 indicates the vertical direction and 2 indicates the horizontal direction. So ideally in this question, since my vec a is a row vector, I should actually call this comma 2. All right. Okay. And the last one is cat, so that is concatenation. And again, once again, 1 is vertical and 2 is horizontal, and 3 here in this case would be depth-wise. So be careful while using them. Be very aware of what dimensions you're using and when, and just keep an idea of the size of the matrix you have, and if it's possible to concatenate in those various directions. Okay, so if I run this code, let me take a look at this. So my n value is 3, which means my mat is 3 by 3, and my vec a is 1 by 3. All right, there we go. Okay, so mat b is reshaped to 1 by n square. So let's take a look at our mat b. This is a 1 by 9. All right, and make sure the sizes are always compatible for this kind of a reshaping question. If you're flipping it, let's see if vec a has been flipped. Yes, it has. So it was 852 and now it's 852 in the opposite direction. And lastly, we have concatenation. We had 258 and 258. So if I double click on this, you will see the two of them concatenated in the vertical direction. all right, which is what one means. You should also be really confident with the sum, average, median, and sort functions. So if you want to take a look at them, they're right here in your notes. So we have a really detailed page telling you about all of these functions. Please practice all the different kinds of sum, mean, median functions and see the different ways you can output them. So you could have just the max of the element, and you could also use this to get the index of the elements. So that is definitely a really important question, and you should know all of this well. An often confused concept is the difference between if statements and else if statements. So the first, if you look at this example, I have my x1 which is equal to 9 and I have my x2 which is also equal to 9. I have written really similar statements in two different loops. So the first one is a multiple if statement and the second one is an if else statements. And let's see how the output changes according to how I write my code. So here I have multiple if statements. All of them have like if, a condition, action, and then ending. All right. So here I have if x1 equals to 3, which is not true. So this part is not executed. Then I move on to the next line. Here x1 is equal to 9. So this is true. So my code moves on to the next line. Here y1 is equal to 5. So the 5 is stored in y1. All right. And we end. Now the loop moves on to the next if statement. So here rem x1 comma 9 is also true because 9 is divisible by 0. So now y1 is equal to 3. So now this y1 value gets overwritten. So it was 5 in the previous line, but now it's 3. So here in this particular sequence of statements, my y1 value is going to end up being 3. However, if I write my code like this, if I use if else if statements, for the first one, x2 equal to 3, that's not true. My statement is not executed. For the second line, else if x2 equal to 9, which is true. So this statement is executed. y2 becomes 5. And since this is true and this has been executed, my else if will not check any further condition and directly go to the end. So let's check if I was right. I'm going to run my code. Yes, my y1 equals to 3 and my y2 equals to 5. Although they are really similar statements, they have the same conditions, they have the same actions, my output will change depending on what kind of if statements I use. This is a really important question and you should definitely understand how different if statements work before the quiz. An important concept that we've visited in homework 4 is taking the code that we have made for one single person and applying that to multiple people. So a good example of that is the Amazon question. In homework 3, you had learned how to write the code to calculate the total amount for one shopper. And then in homework 4, you took the same code and you put that in a loop to find the final amounts for different shoppers. So that is definitely a really, really important question. And a tutorial question that I would like you to visit to kind of get an understanding of how to convert code written for one person into a code written for many people is module 4 question 2. So please take a look at the solution. In this question, we've asked you to write the code for just one person. But if you look at the code given to you, the given script to you, we've already made a loop here that kind of fits in, makes it so that it is applicable for all passengers. So here you have multiple passengers, and what we've done is clear the ages, days, IDs, and now it's like within one matrix called bus data. And we've created a loop called for ii equals 1 to n passengers, and then the test age is all rows first column, the test day is all rows second column, and the test ID is all rows third column. So please take a look at this question, go through the tutorial video for this one to understand how you can take the tutorial video. Basically tells you the code for just one person, but please understand how this given script converts that into a question that's applicable for many people. So you should be able to take code that you have written in the past for just one person and apply it to many people. All right. This is a list of important questions that I've compiled that I feel are really important for you to practice before you take your quiz 2. We understand you're in the middle of your midterm week, so it's probably not possible for you to review all of the content that you've practiced and worked on since the first week. So this is kind of like a concise list of things you should definitely be well prepared with before the quiz. They kind of help you test all the concepts you've learned and also teach you how to apply them to more complicated questions. Ideally, you should solve all of them and also time yourself while doing that. A good way to do that is to just set a timer as you start solving the question and then see how long you take to compile the entire question. Ideally, you should not be taking more than 20 minutes since this is a 120-minute test and you have 6 questions. All right. So here we have, you should definitely review and watch the quiz one solution video. And you should also go through your solutions of homework 4. If you have the time, redo them and just keep them in your MATLAB. All right. For module 1 and 2, I would recommend going back and kind of taking a look at the questions you've made mistakes on, review your errors, see why you made them last time, and check the respective solution videos just so you have a clear understanding of those concepts. And these are the questions for module 3, 4, and 5. I'm going to wait here for a moment so you can take a screenshot of these questions and practice them. In the second part of this video, I'm going to be solving 3 questions that I feel are important for your quiz too. So please watch the second part and follow along with the video.